Okay, this is going to be a BC question, BC Calculus questions 9 and 10, and hopefully you have a fast connection and you can watch this in maybe HD if possible, because I am not going to draw all these graphs in question number 9. But basically what happens is it says the graph of y equals f of x is shown. So they give you the graph of a function. So notice it's got a vertical asymptote at -2, at +2. The function's decreasing from negative infinity to -2. It's increasing in the middle, and then it's decreasing after that. And they say which one of these could be the graph of f prime of x. So we're trying to figure out the graph of f prime of x. To me, the easiest way to do this one, notice if you just look on the inside between the vertical asymptotes, the function is always increasing as you move left to right. And remember, if the function is increasing, so if the original function is increasing, remember that tells us that the derivative has to be positive over that interval. Alright, so between -2 and +2, the derivative has to be positive, which means it has to be above the x-axis. Well, if you look at part A, between -2 and 2, the derivative isn't always above the x-axis. That wouldn't work. D, hey, the function is always positive. The derivative is always positive between -2 and 2. So far, that one seems like it could work to me. B, it's also technically positive between -2 and 2, so that one seems okay to me. If you look at E, it fails as from the same problem as A. It has negative values between -2 and 2. And C also fails for the same reason, down here at the bottom. Well, also if you think about now, so I just have to think which one of these two is correct. And notice as you move as you get closer to x equals 2 from the left, notice the tangent lines, the slopes of the tangent line would get more positive because they would be getting steeper. So that means the y-coordinates, their values need to be increasing as well. So from that you could conclude that it would have to be the graph D. So, alright. So there's that one. Question number 10 says, it's just an integral question, so let me zoom back out here and give myself a little more space. Okay, it basically says if we integrate, so these are e's in the upper and lower limit. So if I integrate from e to e squared of square root of x plus 1 over square root of x squared dx, it says what do we get? Okay, so this one is not too difficult. The only thing you have to be careful about really is just your arithmetic. Make sure that you FOIL out this first part, right? You can't just square the first part and square the second part, which I'm sure a fair number of people will do on the exam. I'm sure I've done it more than once in my calculus career, not really thinking. So just be careful here, because we have to FOIL this out, so let's do that. So e to e squared. So the square root of x times the square root of x, those will just cancel each other out, and we'll just get x. Plus, notice if we multiply x plus 1 over square root of x, we'll get square root of x over square root of x. We'll get root x over root x, but root x over root x is just going to give us 1. Likewise, on the inside, we're going to have a 1 over square root of x times a square root of x. That's just going to give us another plus 1. On the outside, when we multiply 1 over square root of x times 1 over square root of x, we'll just get, well, 1 over x dx. And now, I would simplify down my integrand, so 1 plus 1 is 2. And this is now what I'm going to integrate, x plus 2 plus 1 over x. So if we integrate these a piece at a time, we'll get x squared over 2. That's the antiderivative of x. The antiderivative of 2 will be 2x. And the antiderivative of 1 over x, recall, is the natural logarithm of x. We have to evaluate this from e to e squared. So now it's just a matter of plugging things in and also remembering one of the properties about how you simplify down natural logarithms and exponentials. So so we'll get e squared over 2, so I'm plugging in my upper limit of integration, plus 2 times e squared plus the natural logarithm of e squared. I'm dropping the absolute value because e squared is definitely positive, so we don't really need it. Okay, so my bad handwriting here, it's a little big, so minus, let me plug e in, so we'll get e squared over 2 plus 2 times e plus the natural logarithm of e. And when we go to simplify this down now, let's see, e squared over 2 is going to be e to the 4th over 2. We have plus 2 e squared. Okay, recall that the natural logarithm of e squared, the natural logarithm of e, remember there's a cancellation property, and it says whatever exponent you have, that's going to be how that simplifies. That's going to be what it simplifies down to. So in general, it says, remember, if you have log base a of a raised to something, f of x, then you get whatever the exponent is. So generically, that's the property we're using here. Here we have log base e of e to the 2nd power, so we just get that power of 2 when we simplify. Minus, we have to subtract away the lower limit, so we'll get e squared over 2. We'll get a minus 2e, and then to me it looks like we're going to get a minus. The natural logarithm of e is just 1. So let's clean this up a little bit, a little tedious it looks like to me. We've only got a single e to the 4th, so e to the 4th over 2. I have 2e squared minus e squared over 2. We can get common denominators by making that 4 halves. 4 halves minus 1 half is going to give us a positive 3 halves. E squared, there's a minus 2e hanging out, plus 2 minus 1 will give us positive 1. Okay, so to me that looks like that would be our answer. So again, a little tedious and certainly some little rules that you have to remember. So, alright, I hope these questions make some sense. Feel free to post comments and questions if you have them.